On October 8, 2025, the International Near Object Tracking Consortium released preliminary data on Comet 3I Atlas that challenged 15 months of astronomical certainties. Meanwhile, the European Orbital Coordination Agency kept complementary spectrographic analyses under technical embargo, awaiting an extended review whose deadline no one seemed willing to confirm. Transparency on one side, calculated silence on the other. Between these two institutional stances, a single cosmic object was accelerating in a way that shouldn't be possible. Leave your comment about what you think is happening here, and subscribe to the channel because this story is about to get much stranger. A Boeing 747 would take 17 days to cover the same distance. We're talking about an object that crosses the equivalent of São Paulo's diameter every 1.5 seconds. And this object did not begin its journey in our solar system. 91. Any value above 1 indicates an open orbit, confirming an extrasolar origin. It came from outside, from somewhere between the stars, carrying with it the dust and secrets of planetary systems we will never see. But here's the detail that has kept astronomers awake since October. In just 8 weeks, this interstellar visitor accelerated 320%. Solar radiation heats the surface ice, the ice sublimits, gas jets escape and push the cometary nucleus like small natural jet engines. It's elementary physics, predictable, measurable. The problem is that 3I Atlas's acceleration happened perpendicular to the expected solar vector. Not in the direction the sunlight would push, perpendicular, 90 degrees off script. Now imagine that, halfway down, the car abruptly turns 90 degrees and starts accelerating sideways, without its engine on, without steering, without explanation. That's what 3I Atlas is doing on a cosmic scale. The James Webb Space Telescope began tracking the object in mid-September when 3I Atlas was still 2.4 astronomical units from the Sun. An astronomical unit is the distance between Earth and the Sun, about 150 million kilometers. 2. 4. AU places the comet beyond Mars's orbit, in a region where solar intensity is already only 20% of what we receive here. At that distance, any cometary nucleus should be absorbing heat, gradually warming, releasing gas erratically as internal pockets of ice sublimate under uneven pressure. At this distance, any cometary nucleus should be absorbing heat, gradually warming, erratically releasing gas as internal pockets of ice sublimate under uneven pressure. The thermal analysis team expected to see a nucleus warming consistently with standard models for rock-ice comets. What they detected was an infrared signature 63% below expectations. 63%. Not a marginal deviation of 2 or 3% attributable to calibration errors or slightly atypical composition. The object is too cold, as if it were reflecting heat instead of absorbing it, as if its surface possessed a much higher albedo than any natural comet ever catalogued. The Southern Longwave Observatory, a network of radio telescopes distributed between Chile and Argentina, operates in a frequency range rarely associated with solar system objects. Natural comets do not emit structured radio signals. They produce random noise from charged particles interacting with the solar wind, but nothing harmonic, nothing repetitive, nothing that remotely resembles a transmission. During 3I Atlas's peak acceleration, between September 23rd and 25th, the radio telescopes picked up an electromagnetic pulse at 8.2 gigahertz. The pulse lasted 140 seconds. Within that pulse, an 11 Hz modulation repeated in a rhythmic sequence. 11 Hz, an oscillation every 90 milliseconds, constant, structured, for over 2 minutes. Helena Soares, a radio astronomer at the Brasilia Institute of Space Technology, described the detection as the type of signal you expect from a pulsating magnetar, not from a chunk of rock and ice traveling through empty space. She added that the team ran simulations to rule out terrestrial interference, satellite reflections, instrumental artifacts. Nothing fit. The signal came from 3I Atlas, and only from 3I Atlas. High-precision telemetry from the Mediterranean Interferometric Complex recorded the object's angular velocity over 17 consecutive days, between September 4th and 21st. Natural comets rotate chaotically. Their nuclei are irregular, fragmented, with mass distributed asymmetrically. As they sublimate ice, the uneven release of gas creates random torques that erratically alter their rotation. Angular variation of plus or minus 2 to 5 degrees per hour was expected, fluctuating daily as gas jets activated and deactivated at different points on the surface. The change in 3I Atlas's angular velocity was 0.03 degrees per hour. For 17 days, a smooth curve like a controlled ballistic trajectory, surgical stability. The object rotates as if it had been factory balanced, as if its mass distribution were calculated, symmetrical, intentional. Nature does not produce stability of 0.03 degrees per hour for 17 consecutive days while accelerating perpendicularly to the sun and emitting harmonic radio pulses. Nature does not produce stability of 0.03 degrees per hour for 17 consecutive days, while accelerating perpendicularly to the sun and emitting harmonic radio pulses. 3I Atlas remains abnormally cold. If its surface reflects radiation with an efficiency exceeding 90%, we are talking about a material with optical properties not found in any meteorite, any asteroid, or any cometary nucleus ever analyzed. Water ice reflects about 60 to 70% of sunlight. Freshly fallen snow reflects up to 85%. What reflects 95% or more? Polished metallic surfaces, high-purity ceramics, materials designed to reject heat. Cometary outgassing produces jets that follow the thermal gradient. The side facing the sun heats first, sublimits first, ejects gas first. The resulting force pushes the comet away from the sun, or slightly to the side if the jets are asymmetrical, but always within a predictable cone aligned with stellar radiation. 3I Atlas accelerated at a right angle. For this to happen naturally, gas jets would have to be activating exclusively on the object's night side, in the coldest region, where sublimation should be minimal. It is the opposite of what is expected. Natural phenomena produce broadband radio signals, noise distributed across multiple frequencies simultaneously. Lightning emits broad spectra. Planetary magnetospheres emit broad spectra. Even pulsars, the most organized natural objects in the cosmos, emit pulses that sweep frequencies as they rotate. 3I Atlas emitted a near-pure tone at 8.2 gigahertz, modulated at 11 hertz. This is the signature of a harmonic oscillator, of a vibrating piezoelectric crystal, of electronics. We are facing an object that rotates with mechanical precision while accelerating asymmetrically. The two anomalies contradict each other unless the mass distribution is actively controlled, unless something inside the object is compensating for external torques. Fifth anomaly, the temporal window. 3I Atlas was detected 15 months ago in July 2024, when it was still beyond Jupiter's orbit. For 13 months, it behaved like a normal interstellar comet. Predictable trajectory, no anomalous acceleration, no radio emissions, rotation within expected parameters. Only in the last 8 weeks, as it crossed the 3 astronomical unit mark, everything changed, as if something had switched on, as if a dormant system had awakened upon detecting sufficient levels of solar radiation. Then, upon entering a star system at a specific distance from the sun, protocols activate. Reflecting surfaces orient themselves. Directional jets fire. Radio signals are transmitted. For 140 seconds, someone or something says, "I am here." Or we are interpreting signals where none exist. Naturalistic explanations have been proposed since the first data release. The most popular involves asymmetric sublimation of carbon dioxide. Comets contain frozen CO2 in internal pockets. Under certain pressure and temperature conditions, the CO2 can explosively sublimate, creating powerful directed jets that do not necessarily follow the solar thermal gradient. If 3I Atlas has unusually distributed reservoirs of supercompressed CO2, perhaps the perpendicular acceleration is explainable. If the reservoirs were active, we should see visible gas jets, dust clouds, and expanding cometary coma. Optical telescopes detected none of this. The object remains clean, without coma, without a tail. Where is the gas that supposedly pushes it? Some celestial bodies preserve residual magnetic fields from their formation epochs. If 3I Atlas contains highly aligned ferromagnetic minerals, it could interact with the interplanetary magnetic field in an unusual way, generating apparently anomalous forces. This interaction could also, in theory, produce electromagnetic emissions. And magnetic fields do not modulate radio signals at harmonic frequencies. They produce broadband noise, chaotic emissions. 11 Hz repeated for 140 seconds requires something oscillating mechanically, not magnetically. Perhaps multiple observatories, using different independently calibrated instruments, all made errors that, by coincidence, point to the same set of anomalies. Perhaps the James Webb underestimated the thermal signature. Perhaps the Southern Long-Wave Observatory picked up terrestrial interference disguised as a cometary signal. Perhaps Mediterranean telemetry excessively filtered data, creating artificial stability. It would require scientists on 3 continents using distinct technologies to fail in mutually reinforcing ways. It would require all cross-checks, all artifact disposal simulations, all internal reviews to fail simultaneously. The probability of this is less than 0.1%. Errors happen, but errors do not conspire. Perhaps 3I Atlas is the first example of an entire class of interstellar objects that, under specific conditions, exhibit behaviors mimicking artificial signals. Perhaps the combination of atypical composition, unusual geometry, and unique thermal history produces all these anomalies without needing extraordinary hypotheses. It is the position science should adopt as a default. Do not multiply entities beyond necessity. But caution is not blindness. When Occam's razor begins to cut against its own logic, when the simple explanation requires more ad hoc assumptions than the complex explanation, it is time to consider alternatives. When Occam's razor begins to cut against its own logic, when the simple explanation requires more ad hoc assumptions than the complex explanation, it is time to consider alternatives. The word probe appears in private conversations among astronomers, always followed by, but probably not, or an absurd coincidence, and it would be. The chances of an interstellar technological artifact crossing our solar system during the brief period when we have instruments capable of detecting it are astronomical. 1 in 10,000, 1 in 100,000. Depending on assumptions about the density of civilizations in the galaxy, perhaps 1 in a million. Small, inert during interstellar transit to minimize degradation, programmed to activate upon detecting stars, coated with reflective materials to resist the erosion of interstellar particles over millions of years, equipped with sensors, guidance systems, perhaps basic communicators to transmit data back to their origin, until primitive sensors, perhaps simple photovoltaic cells, detected increasing levels of stellar radiation. A threshold would be crossed, internal systems would begin to awaken, long-duration batteries or radioisotope generators would power ancient computers beyond any human archaeology. Protocols would be executed, the probe would orient itself, it would transmit. Probes on interstellar trajectories make a single pass, collect what they can, and vanish back into the void, exactly as 3I Atlas is doing. A hypothesis that cannot be proven without direct evidence, without surface analysis, without high-resolution spectroscopy looking for signatures of manufacture, and we have 10 weeks to get that evidence. Perihelion is the point of closest approach to the Sun, when the object will be just 0.8 AU distant within Venus's orbit. After this pass, 3I Atlas will irreversibly accelerate out of the solar system at 110 kilometers per second. Every hour after perihelion takes it another 400,000 kilometers away. Each day adds 10 million kilometers to the separation. In 3 months, it will be beyond Jupiter's orbit. In 6 months, beyond Neptune. High-resolution observations become impossible. The window closes. If 3I Atlas is a rare geological phenomenon, the only thing we lose is the chance to study a new category of celestial body. We will learn less about exotic cometary processes. Scientific papers will not be published. Models will not be refined. It's not the end of the world. The universe will continue to send us interstellar visitors, perhaps one every decade. And eventually we will capture another with interesting properties. But if 3I Atlas is something else, if it is a technological relic, an artifact of cosmic archaeology, and we let it slip away, when will we get another chance? Oumuamua passed in 2017, 8 years until 3I Atlas. If the next interstellar probe arrives in 2034, will you be ready to wait? Will your children be? In 70 days. This is how science should always work. 2 weeks? 2 months? Beyond perihelion? No one is saying. And the longer they remain silent, the more speculation fills the vacuum. When you have data that could rewrite textbooks or simply baffle casual readers, the temptation is to hold back, recheck a dozen more times. Wait until you are absolutely certain. But absolute certainty does not exist in science. There is only accumulating evidence. And evidence has an expiration date when the object of study is accelerating out of reach. The official response remains await review. CNSA has demonstrated the ability to prepare missions within compressed windows. Technically, it is still possible to launch an intercept probe. Technically. 5 weeks to approve the mission, integrate instruments, prepare the launch vehicle, calculate rendezvous trajectories. Space missions normally take years of planning. 5 weeks is time to design the mission logo, not to build the craft. Suppose some space agency, anticipating exactly this type of scenario, has a rapid response interceptor in modular preparation, infrared and optical sensors, mass spectrometer, high-resolution radar, cameras, all miniaturized, all tested, awaiting only final integration and fuel. Launch in 3 weeks, rendezvous on December 20th, 2 weeks before perihelion. The spectrometer analyzes surface composition, looking for elemental anomalies, metallic alloys, refined carbon compounds, anything that doesn't form naturally. The radar maps internal geometry, looking for cavities, structures, suspicious symmetries. The elemental signatures, metallic alloys, refined carbon compounds, anything that doesn't form naturally. The radar maps internal geometry, searching for cavities, structures, suspicious symmetries. If 3I Atlas is rock and ice, images will show an irregular surface, impact craters, stratigraphic layers. The spectrometer will detect silicates, iron oxides, water ice, perhaps traces of simple organic compounds. The radar will reveal heterogeneous density without geometric patterns, without compartments. We will publish the data, update cometary formation models, celebrate a successful scientific mission, and move on. But if the cameras reveal panels, junctions, surfaces that are too smooth, geometry that is too regular, If the spectrometer detects titanium aluminum alloys or silicon nitride ceramics, or any material that requires industrial processing. If the radar shows internal chambers, corridors, symmetrical components arranged with evident purpose, then we will rewrite more than cometary models. We will rewrite our position in the cosmos. If we decide that 5 weeks is insufficient time, that the risk of mission failure is too high, that the cost is not justified without prior certainty that the target is exceptional, then we will observe from the ground. Telescopes will continue tracking as far as possible. We will collect more spectra, more light curves, more angular velocity data. We will try to extract certainty from pixels. In 2027, it will be just another data point in catalogs of interstellar objects. In 2030, astronomy students will read about it in footnotes. The interstellar visitor with unresolved anomalies, a candidate for future studies should similar objects be detected. Because the extraordinary demands extraordinary proof even before we investigate. Sharing resources, dividing responsibilities, accelerating approvals? Perhaps. If the political will exists, if the embargoed spectrographic data are released and confirm that something is genuinely wrong, if enough senior scientists pound enough tables demanding action, or we observe, record, debate, and let it pass. But observing also doesn't answer questions when the object of study is fleeing at 110 kilometers per second. A harmonic radio pulse that natural comets do not emit, rotational stability that chaotic objects do not exhibit, a 70-day window of opportunity before everything disappears beyond reach, rotational stability that chaotic objects don't display, a 70-day window of opportunity before everything vanishes beyond reach. Either we confirm that 3I Atlas is the first documented example of a cometary geological phenomenon we've never seen before, expanding our understanding of how icy bodies behave during interstellar transit, or we are forced to consider that, for the second time in 8 years, something not entirely natural has crossed our solar system. And this time, we were fortunate enough to detect it while it was still within reach. The other expands everything. Perhaps it was just the cosmic equivalent of a mechanical clock ticking as ancient gears awoke after millennia of hibernation in the cold void between suns. A brief, functional declaration transmitted by something that never expected to be heard, merely fulfilling protocols programmed eons ago by engineers who turned to dust before our species discovered fire. If it's true, if 3I Atlas is indeed a technological relic traversing the abyss between stars, then the universe is not empty in the way we thought. It's full of archaeology. Full of messages cast at random, traveling for millions of years, crossing silent star systems where no one listens because no one has evolved yet, or has already gone extinct, or simply looked away at the wrong moment. What will we do with this window? Will we merely observe, record, carefully debate as the object escapes, comfortable in the certainty that we acted with appropriate scientific caution? Or will we risk launch, reach out, touch, and discover if we are alone, or if the universe is whispering to whoever has the courage to listen? Not in years, not in months, in weeks, in days. The universe paused for an instant to watch us back. The question is, are we paying enough attention to notice?